Hello everyone, my name is Nguyễn Quang Minh from Hanoi University of Mining and Geology. I would like to introduce a session on classification and clustering. This session of the course presents a brief and knowledge on the major tasks of the geospatial works. This is classification and clustering. Firstly, I would like to introduce the overview of this presentation. The objective of the presentation uh, will be presented first, and some very basic terminology are introduced. Then the terminology such as land cover classification and clustering is presented to help you to understand what the objectives of this classification, which algorithm may be used for the task, and finally the introduction of the artificial intelligence, very famous term at the moment. Uh, is introduced and the application of them for the classification of land covers was also introduced. The objective of this presentation is about introducing the terminology of land covers, how the raw data acquisition for the land cover, the raw data such satellite and aerial imagery are acquired, the description of the land cover classification methods, and the introduction of how artificial intelligence and machine learning apply for land cover classification. Of course, land cover classification is the main topic of the other model, the Earth observation. However, in this session, present the classification and perspective in the perspective of artificial intelligence or machine learning, which mainly used for land cover classification. First of all, I would like to introduce the concept of land covers. The land covers may refer to the observed physical and biological cover of the Earth's surface. The land cover are categorized into classes such as vegetation, land grass data, forests, water bodies, rivers, lakes, ponds, or seawater. The barren soil or lands, the construction land such transportation, houses and buildings, and the other man-made features. Uh, the land cover classes categorized based on the requirement of the users. In very close term for land cover is the land use. The land use is socio-economic description of the land surface, such as residential, industrial, and commercial, etc. The land use are defined by human and sometimes not depend on what we have on the ground. Land use mostly correlated with the land covers. For example, the vegetation land cover show very high possibility of agricultural land, or the place with the forest land cover is very likely to be the forest land use type. However, this correlation would not be in all the cases. For example, an area of mixed construction and vegetation land covers may not may present both residential and commercial lands. Here's some example of land cover in Vietnam from 1990 to 2020. At this scale, the land covered classes would relatively very general. The resident land may consist of transportation, buildings, and houses, and other man-made landscapes, which class, while the class related to the vegetation are categorized quite detailed, such as cropland, rice paddies, grass, scrubland, or forest. And similarly, the open water, it should be open water and aquaculture and even wasteland. The land cover classes information obtained from satellite imagery or other remotely sensed data, such as unmanned vehicle. The process of obtaining land covers from remotely sensed data is the land cover classification or clustering. To understand the classification of land cover classification, it is necessary to know about the process of remotely sensed imagery acquisition. First of all, the imagery of data are obtained by sensor in the satellite or other carrier such as UAV, mobile mapping. The imagery are sent using scanning or frame cameras. For satellite imagery, the scanning sensors are mostly used and there may be push broom or whisk broom such as Landsat 7. The framing camera is also used but not very popular because the very far distance from the flying carrier, which is a satellite, and the Earth's surface. The most popular data are multispectral data, which based mainly on the visible wavelength electromagnetic waves. The sensors are used to collect the reflectance of the location of the Earth's surface at a particular wavelength bands. The red bands, for example, are a layer of pixels which present the reflection of the Earth's surface at the red wavelength around 612 to uh, 750 nanometers. Radar data obtained from the longer range of the sensor or the longer wavelength of sensor. The other data is the hyperspectral. The hyperspectral is very acquired using hyperspectral sensor, which is very sensitive to very short intervals of wavelengths. Uh, Therefore, the hyperspectral remote sensing data often involve to the very large number of spectral bands. One dataset may consist of more than 100 bands in a certain scene, or even more. To this one is used to provide the detailed information on analysis and research purpose. Another concept I would like to introduce is pixel. Pixel in remote sensing are square that represent the reflected light energy recorded in different parts of the image. They are building blocks for interpreting the remote sensing data. The area covered by a pixel may present the spatial resolution. The resolution may be vary from sub-meter to 100 meters or even closer a kilometer. Aerial flying vehicles such as airplane or unmanned aerial vehicles can be used also for uh, to carry the sensor. Due to the close range of this vehicle, the imagery uh, obtained by them are more likely obtained by frame cameras, and they are more likely a photo rather than a spectral image. This image will show some uh, most popular raw data of the Earth's surface exploration. It's a remote sensing satellite image. This showing how remotely sensed imagery are acquired. The image shows different kinds of sensors, such as the point scan, the line scan, also the spectral scan, or we call the line scan we call push broom, and the spectral scan is kind of framing sensor, and the image mapper collects data using snapshot. The satellite carrier sensor is designed to fly in an orbit that is sun-synchronous, which, which means every image is scanned or captured at about 10 a.m. every day, and the footprint of the scanning area is called flying shots of the satellite. Um, this is the demonstration of the health multispectral and hyperspectral data. The multispectral data has fewer number of bands, you can see, and each band covers a discrete interval of the wavelength, and the hyperspectral has almost continuous spectrum. It means that there are many number of bands on the hyperspectral, and it's able to detect the feature which are very slightly different in terms of spectral characteristics. But we have problem with the spatial resolution, and it's used mostly for closer range sensing. So now we have the data, the raster data of spectral bands with a matrix of a raster image, and each pixel which present an area on the Earth's surface is a vector of Rho value. This Rho value may range from 0 to 256 for each bit image, or 201 to 0 to 100 1024 for 11 bit image. The vector of B spectral band has B dimension. For example, a pixel of multispectral image of 4 band like in this image represented by a vector of 4 dimensions. The space created by the key value of the spectral band is called the feature space. It means the feature space defined by the capture band. For example, in this space we have H as the vector. X include H1, H2, and HB represent the gray value of H band. After training, we have an algorithm to know about the signature of the training area, so that we know which in this training sample we already know which is urban. For example, the urban has a gray value of 100, 111, 99, 78, or 0 or 9. For example, the river has value of 12, 11, 19, and 22, and the forest of the value of um, 60, 22, and 36. So we compare the feature defined by the capture band can be trained in the learning process, and then after learning process the algorithm know already the pixel which pixel value the pixel which this value belong to which land cover class. For example, this one might belong to the urban land cover class. In machine learning, the term supervised and unsupervised learning is very fundamental. The supervised learning is a process of training the algorithm with the labeled samples and then use this training model to predict the labels of the known sample. Unsupervised learning categorizes the sample by their natural characteristics. With supervised learning, it is necessary to have some training sample, which is data with known values. For example, for the class question, the labels of the samples are known. This training data set must be collected before, and the accuracy and the number of training samples are quite affectable to the learning results. Projecting this term to the geospatial field, the supervised learning may refer to the supervised classification, where there are a lot of number of pixels with known label land cover class, and the unsupervised learning term as unsupervised classification or clustering. The training samples can be collected using field survey. For example, we go to the field, collect where is the forest, where is the construction land, and use a map or image with higher resolution to just show clearly how the class level, and we collect that data, collect that location, and we set up a kind of training data. Firstly, we introduced about unsupervised learning. The unsupervised learning is the process of categorizing the objects into classes based on the similarity of their characteristics. In this image, I would like to show you the three kinds of different objects. This kind of object will be put into the algorithm as raw data, and based on the characteristics, for example, the pyramid image with colorful image is classified in one class. The cubic white will be classified into one class, and the sphere object will be classified into one class as output. In the spatial terms, this is categorize the pixel into classes based on similarity of the pixels. And the pixel in the same class is very similar. The labeling for the class sometimes is a problem because we don't have expected land cover class just based on the natural characteristic of the pixel. The other term is the land cover classification and is supervised learning or supervised classification. Supervised classification is a classifying process based on the known data or training data. You can see that we have some area we call region of interest. For example, A is water, B is agriculture, and C is rock. And based on that training data, we can use a learning process, and then after the learning process, the model will understand which pixel what type of pixel will be classified into water, into agriculture, or into the rock. And the classification is the process of labeling a pixel into class based on vector in the feature space. So we should know about the feature space